Hi, all. Glenn Kirshner. No, I'm not Glenn Kirshner. That's right. Just your lowly math teacher here, ready to do part B of the handout that you've been given to prepare for a series of tests, which you can consider all final exams. 5 tests in the next 3 weeks, 4 weeks of study. We're looking for your best effort. I don't think you can do a math problem correctly unless you know what it's asking you to do. And you have practiced enough to understand it and work with it. So we're going to give you that opportunity a number of times in a row. And hopefully you can learn from your mistakes and get better and better scores each and every time. All right, so we're going to do some warm-up exercises here. Quick comment. I just learned from another student that you can make comments on the videos if I click Made for Adults. I thought that, well, I'm not sure what I thought, but happy to hear from you. And let me know if you think that this approach is helping you or not. I don't know. Whatever kind of comments you want to make, fine with me. So let's get some warm-up exercise. Oh, in this video, I will be talking about how you might be using some of these calculations in the future. Certainly problems 30, 31, 32. I've already thought about some things I want to say. 39. You might want to make sure you click on some of those because I think I might be saying something a little bit differently. I'm sure I've already said these things during the course of the semester, but maybe not enough repetition for it to have clicked. Maybe just in passing, I've made some statements. So you might want to spend some time with those problems. But let's get some warm-up exercises going. I mean, you always, you know, if you're playing a sport, you always warm up. So let's do that. Let's get our arm ready to go. Get the shoulders working. Let's assume the position. Let's get the frown, and let's maybe, what am I looking at here? Let's practice thinking. Oh, let's practice a little patience. A little more thinking. All right, well, that's what you actually have to do if you want to move up the ladder in this discipline, because a lot of times the things you're looking at don't necessarily come to you immediately. You have to sit with them. You have to hear about things. You have to follow someone doing a problem and listen to how it's done, examine how it's done, start thinking about the numerical ramifications of a problem, the geometric, the graphical implications. There's a lot that goes into developing a mind that can work mathematically. Mine is trapped between Algebra 1 and Calculus AB. Okay, but I've spent a lot of time thinking about those things, getting a lot of repetitions. And repetitions, I think, are the key to success in this discipline. And I think it's the key to success in any sport you play. And certainly familiarity with whatever job you might end up doing in the future. I think you're going to learn that learning is fun, and that learning is oftentimes based on the number of repetitions that you do something. Okay. All right. So there's a little rant. We'll get started here. And anything else I want to say? Yeah. Hopefully you've done enough repetitions that the problems, many of the problems that we do, you look at and you go, oh, that's piece of cake. That's easy. And if you're saying that, then you've put in some good intellectual effort and some good practice, and you've put in the effort necessary to work with it effortlessly. And that's the goal. All right. So let's have at it. And been up for a while. It's a beautiful day, but now we're turning our attention to the board. And I think you can see everything. So I thought I might have done this one on the last video, but the square root of 28 can be written as the square root of 4 times the square root of 7, which is 2 root 7. I'm not going to spend any time on that one. How do we write this equation? Well, hopefully you recognize that squaring is the signature here that you're looking at, numerical signature, and minus 3/5, x plus 3 plus 5 gets us started. And then this is a minimum value. So when we ask for a max or a min, we're looking for a y value. And that minimum occurs when there is no area to the squaring process, because every other number that you plug in besides 0 and 0 makes this number go up. So -3 to 4 is a change of 7 units. And if I put 4 into this equation, I get 49 plus 5. 49 plus 5 is not the number 9. No, it is not. So let's get rid of that 49 units of change. And let's bring in the change we need to get from 5 to 9, which is 4. Okay, so we've been doing that now for, well, since the end of August. Technically, I suppose I should write equals y. I think it's better if equals y was over here, because then you're in a better format of plug a number in, have a number come out. Is there anything else worth saying there? Yeah, you got the roots right in front of you. You're measuring from -3 and you're adding and subtracting the square root of the change necessary to get to 0, which is an imaginary change. Now you're actually pretending that it's going in the other direction to get to these x's. And how far do we have to go? So I'll show you where the I comes from, because we are going to be talking about that. -5 divided by 4/49. And if you're dividing by 4/49, then you're really multiplying by 49 and dividing by 4. Okay, and I'm not going to get into, but we write I, move the negative out. You will be working with that down the road. We haven't spent a lot of time in this process, but parts of it we spent a lot of time with. We just haven't really been looking at imaginaries enough, but there's another rep. Okay, and that therefore will help you when you do concentrate on examining this in a little more depth. All right, so 4x squared plus 5 equals 20. We want to do it mechanically, and we also want to see what's going on visually. I think I'll erase these as I go along. Probably shouldn't have done that. So let's come back here, and I might summarize, get one more rep in rapid fashion, maybe. I might try that. So this was -3,5. This is 4,9. I'm going to probably at the end of this video fly through this and do it in rapid succession. All right, so what's this? It's 15 divided by 4 plus minus the square root of 4. Is it really 2? Plus and minus 2? 4, 16. No, I made a mistake somewhere. Subtract 15. Oh, what the heck did I do? Divide by 4. That was a classic error. All right, so 15 divided by 4. And then we got the plus minus square root of 15 fourths, which could be written as the square root of 15 over 2. Doesn't hurt to check that. 4 times the square root of 15 plus or minus over 2 gets squared, and we add 5. So what do we get? Well, if I square root of 15, I get 15. If I square 2, I get 4. And if I square plus or minus, I get positive. And then if I add 5, we can see the 4's cancel. 15 plus 5 is 20. One way to check to make sure it works. So you catch what I had earlier, which was a careless error, because I was talking too fast trying to get this video in front of me. All right, so square root of 15 is pretty close to the square root of 16. 16, square root of 16, 4 divided by 2. I'm pretty close to the number 2, plus minus, for answers. So let's look at it graphically real quick. So 4x squared plus 5 is 4 times x minus 0 squared plus 5, by the way. So that's a product. How do I make x squared a minimum? It's got to be 0. So 0, 5 was your vertex. You're going up very quickly, 4 times the normal squaring process, and hitting a height of 20 at some point. Well, 20 is much. Let's do a better job. Here's 5. Going up quickly. All right, and that's 5, and 20 might be there, 4 times that height. Okay, is it believable that that could be positive 2-ish, negative 2-ish? Absolutely. All right, so it's nice if you come at a problem from 2 different perspectives, so that if you make a mistake and you do the problem the same way again, you might make the same mistake again. But if you do it a different way, the odds are in your favor that you'll catch your carelessness. All right, so what have I got here? I've got, I hope folks can just write the answer down on your answer key, and then it's a 5-second question, because you need to turn this fraction, you got to reciprocate it, and then square the number 3. Okay, so reciprocal and square it. For those of you who are still looking at that and have not yet processed it, we have 1/3 to the x. That's understanding what's being asked. Okay, if you're asked to find the exponent on top of a third, that gives you the number 9. Okay, it's not much you can do here. You need to know that that minus sign reciprocates that. Okay, so this is 3 to the -1. And the rule of exponents is multiplication there. -1 times x minus x. And 9 is 3 squared. So minus x equals 2. X equals -2. There's a mechanical way to see it. All right. Is there anything else I want to say about that? Not really. Not at this stage. All right, some basic factoring problems. Okay, am I recording? I hope I am. Yes, I am. So when the coefficient is 1, we're looking for 2 numbers that multiply out to -36, and those 2 numbers add up to -5. Okay, so what are the factors of 36? 1 and 36, 2 and 18. Take a 3 out of that, and it becomes 6 and 3. Let's see, how do I get 4 and 9 out of it? I guess if it's even, that's probably the best thing to do, is start with the smallest number that's contained. So if that's even, 4 times 9. Once you see something like that, you stop and you go, okay, what makes that -5, -9, and +4? Okay, so we got our x minus 9, x plus 4. I suppose if we really want to make sure that we haven't made a careless error, I do all the time because I'm doing them too quickly, so that I can get things in front of you, and the reps usually take care of any carelessness down the road, get more familiar with each calculation. So what do you do? Well, I pick a number like 1. 1 squared is 1, -5, -36 gets me -4, -36 gets me -40. So I put a 1 in here. -8 times 5, -40. Okay, absolutely no carelessness. Move on to the next problem. 3x squared plus 30, graphing form. It's actually quicker to get graphing form to just sketch it. Graphing forms are there so you can see the sketch. You want to be able to see the sketch without writing the graphic form. So we got a cup shape up. I'm on the increasing side for my y-intercept, 0, -7. And I want to get the vertex, so I've got to get myself minus b over 2a. I know it's negative because here's the number 0. This might be helpful to you. Put a horizontal ruler, call it the x, don't have to call it the x-axis, but just the x horizontal ruler. That's 0. Many of you have had trouble with mixing your x's and your y's. I'm to the left of 0, so it's going to be a negative number, right? So what I do is I just divide 3 into 30, 10, cut it in half, and I know it's -5. But if you need to take more time with it, minus b, minus 30 over 2 times a. There's your -5. Okay, now we plug -5 in. That's -150. Cut in half is -75 minus 7. So we got -82. Okay, why did I cut that in half? Well, let's take more time with -5. -5 squared, 25 times 3 plus 30 times -5 minus 7. That's 75. That's -150. Minus 7. Now, what do you get when you do 75 minus 150? You get -75. And -75 is half of that middle term. So that's how you can get that quickly. All right, so what is the graphing form? I guess that was the question asked. The graphing form is take the 3, it's given, it's a gift, you take it, I should start here first. A, x minus h squared plus k. Okay, why the letter k? Because ax squared plus bx plus c, c is taken already for a different form. Okay, I tell my grandson, you know, I don't know what he's getting for education. He spells cat, C-A-T. We all know cat spelled K-A-T. So that's a shout out to Bryce. All right, but yeah, so it stands to reason that, you know, it's a different letter. And H stands for B over 2A. Well, I want to be careful when I say that because H is really here, right? So this H is minus B over 2A. But if we're subtracting it, we end up with a plus. I'm on a tangent. Let's get back to basics. All right, so what's given? 3. What did we learn? Minus 5. So we want to say plus 5. All right, so that we can get a minimum. Again, I talked about the minimum a moment ago. You know, that's the minimum area for a square. And that number makes it happen now when I write that. All right, and then, where am I? Minus 82. That's the graphic form. All right, and I think I asked for the roots as well. So where are the roots? Minus 7. The roots are here at y equals 0. So I need that x, and I need that x. And to help me do that, I need that x, which is that number. That number, I got to add something to get to the second root, and I got to take away something to get to the first. So immediately, I can see my x value is minus 5 plus or minus. How do I get from negative 82 to 0? I got to go, well, I'm not doing the square root yet. I got to go up 82 units. But if I'm tripling that, then I only want a third to start with. And if I'm squaring it, so those are really the inverse operations. And I will show that over here. Okay. How do I get from negative 82 to 0? Got to go up 82. Boom. Multiplication by 3. Division by 3. Boom. Squaring becomes plus minus square rooting. Boom. Addition of 5, subtraction of 5. And this has been done in previous videos given for homework, so I'm not putting it up there again. All right, but you should take the time, plug it in so that you can see it comes out of 0. All right, so let's erase that. Okay, let's go here. And then if you want to practice that again, we're going to do it at the end of the video. All right, so what are we looking at here? We're looking at a guy that's moving the camera around and not even sure if he's capturing the screen. I've been up since 4:30. It's starting to show already. All right. So this is a parabola, just so we know. Vertex is at 3, 5. Would have been nice to move the 5 here. You see it a little more easily. Okay, but the 5 is over here. And we're going to expand this into the ax squared plus bx plus c form. Okay, so let's do it. Step 1 might be helpful. Move the 5. We don't have to write a plus sign in front of every number. We understand it to be an addition of 5. Brackets are helpful here. If you have to do at this stage of the game, x minus 3 times x minus 3, go ahead. But most folks know to do this. That's where I'm going at this stage. And so final answer, minus 2x squared plus 12x. In your head, minus 2 times 9, minus 18 plus 5. I think you probably could do that, minus 13. But what's a nice thing to do here? Probably start with a check. Why don't we let x equal 3, see what this becomes for a y value. I hope you can see 5 easily, which means if I put a 3 in here, it's got to come out as a 5. So minus 18, right? 3 squared 9 times negative 2 plus 36. There's that 2-to-1 ratio again, minus 13. Adding that gets me 18 minus 13, that's 5. no carelessness, move on. I don't think I will do this as a summary at the end of this video. I think I might fry my brain. It's already fried. All right, next one. 3x minus 7y equals 42. Graphing. All right, so what's the x-intercept? The x-intercept 3 and a 42, it's 14. We'll call that 14 for an x-intercept. Minus 7y equals 42, negative 2. Boom. If you don't understand that, then get a tutor from the class, because we've done that a lot and pretty basic stuff. So we plug in a 0 for x, right? And if we have trouble again, remember, drop an x-axis. It's not an x ruler underneath your work. Highlight 0. Okay. If I move to the right, going up on the number line, and to the left, going down. So 0, negative 2. So where's this? This is the 14 to the right. No height. Might be nice to have a wide ruler over here where there's no height. Okay. All right. So that was that graph. So 3a squared plus 2a minus 8. It's not so simple as the last factoring problem we did, because we've got a coefficient that isn't 1. So what we have to do is we have to have 3 times 1 parentheses times another parentheses gets us negative 8. And 3 times 1 parentheses plus another number gets us 2. So what are the factors of 8? Plus minus, right? Of negative 8, plus minus 1 and 8 and 2 and 4. So not that many things to worry about here. So what works? 3 times, we want 2. So I'm looking at, I think 2 and 4. 3 times 2 is 6 and negative 4. 6 minus 4, 2. Let's see if that works. So 3a in this case, and a, and I need 3 times 2. So I'm going to write plus 2 over here and minus 4 there. And I think I've got it. Let's check it with a number. Let's put 0 in and see if it comes out as negative 8. So we put a 0 in, we get minus 4 times 2, negative 8. Let's put a 1 in just to make sure that there isn't some aspect of putting 0 in that's problem. So if I put a 1 in, 3 plus 2 is 5, minus 8 gets me negative 3. Remember, algebra is supposed to work for all numbers. So let's put a 1 in. 3 minus 4 times 1 plus 2 minus 1 times 3 is negative 3. Okay. I think that problem is a check. Okay, what's next? Whew. All right, problem number 30. I got to move this desk, I think. I got to be careful that I make sure the screen. There we go. Yep, that looks good. All right, so I said I might talk about this in a little more detail. All right, I'm hoping people know that's 0 when x is 0. That parentheses is 0 when we got 81 over 73. And that's 0 when we have 3 halves. So those are our answers. Let's look at it from a graphical perspective, though. So if I put a really big number in, that's going to be negative. Really big number, that's going to be positive. Really big number, that's going to be positive. So I know I'm looking towards negative infinity. The bigger the number I plug into this. We've had that discussion. And this is a sign chart. We're working with a sign chart, but in future classes, it's a whole lot easier to analyze some of the things you're going to be studying graphically. So in my calculus classes, I like to start off with a picture of Massachusetts, New Hampshire. And I like to think of Route 91 as the y-axis, which measures amounts. But the question is, what amounts? Well, you're going to find out that the functions you're working with are going to get initially kind of linked with position, velocity, and acceleration. And usually we can talk about these in a physical context with respect to time. So let's say that the number 1 corresponds to 1 hour into a journey. Well, what do we know 1 hour into a journey? Position-wise, we get, wish I picked some easier numbers here to get you started with this. So if I did put, I'm committed here. I've already put myself into the conversation. So we put 1 in, we get -5 times -8 times -5. Okay, so that's a negative number, -200. -200 puts grandma, who's driving on Route 91, either on Long Island Sound or in the water. I'm not sure. But either one of those bothers me. And if this was a velocity, then we would say on Route 91, she's traveling south at 200 miles per hour. And if it was acceleration, she's accelerating in that direction, 200 miles an hour every hour. All right, so why do we study math? Well, in this context, we think grandma's having some trouble here. And so we better get out there and rescue her. I think it's a little too late personally, but what I'm basically trying to say here is that the things you're studying right now, you continue to work with and you use them to start studying relationships out there in the real world. And if foundationally you can't move in that direction, then you have to stop studying this discipline. And that's true of probably 90, whatever, some high 90%, 97% of the population. Right? And you give yourself a better chance of moving up the ladder if your foundation is strong. So, not asking you to graph this on your final exam, but I'm just going to graph it quickly. Each of these is a linear term, and linear functions cross the x-axis and at constant rates. Okay, whereas quadratics, you don't get sign change. Cubics, you do, but there's reasons, geometric reasons why it's different than that. And we'll be looking at those as well as we move up the ladder in the discipline. Hopefully your next level of study will begin to look at this in more depth. All right, so what do I know? I've got three places that, well, I've been got to be consistent. I use dashes, right, to show that there's going to be sign changes. So there's a sign change at 3/2. There's a sign change at 81. over 73. Yeah, that's smaller than that. Okay. And at 0. Okay, so my graph looks like this. And now if I was going to look at velocity, velocities are positive in these intervals of time. So therefore, grandma would be heading north on Route 91. And for the negative y value south. Again, I'm not testing you on this. I'm just giving you a little glance into the future. All right, if I was studying this from an acceleration standpoint, then we talk about whether a graph, you know, the original function is concave up or concave down. And so if you can't do this, and that's going to be your next class, your Algebra 2, going to be graphing these in more detail. The inability to do that prevents you from discussing entry-level work where the math gets used to find information, to study phenomena out there in the real world. Okay, so I've not rehearsed this, obviously, but hopefully I'm saying some things that resonate and get you those first reps, because understanding that's going to take a variety of reps. Did I even solve the problem? Now let's go back to the sign chart. All right, so we got minus 5x, so we got a 0, 81 over 73, 81 over 73, and 3/2, right? So those are the, okay, and we just found out from the previous work that if I pick a number big, well, I don't know if I picked the number, but let's put 1 million in here. -5 times a million is a negative amount. A million there is a positive, and a million there is a positive, and that's a negative number. Well, we're just solving for zero right now. So negative number, all we did was equal zero. Geez, I'm sorry. Here I am thinking that I'm doing one of these problems. Greater than zero. Since I've started this problem, let's, all you needed to do was give me those three numbers. So I'm going off on a real tangent here. But let's finish up with just doing a sign chart, pretending that this problem was for greater than zero, because I'm sure we're going to be doing that too. All right, and so I just found out that picking any number bigger than 3/2 made this negative, so that's false. Then that's going to be true, that's going to be false, that's going to be true. And I've already talked more about this problem than I should have. All right, let's move on. A disjointed video. Let's ask over here. Minimum. Let's get this chair out of the way. All right, so minimum. 10 minutes ago, we talked about the y value of a vertex being the minimum, so that's all you have to find. Okay, so what do we have? Minus b over 2a, 16. Critical number for x is 3. And the minimum is going to be that y value, so the 3 squared. 9 times 3, 27. That should be minus 54. Double will change the sign, plus 1. So this is minus 27, the opposite of that, plus 1. So your minimum value is negative 26. F of x. Did I want to say anything else about this? How might I have done it? Would I have done it the same way? Probably not. I probably would have just come in here and said, okay, I got the 3. I know if that's positive and that's negative, that's negative. So therefore, I just 3 into 18, 6 cut in half is 3 squared. Completing the square, that's positive 9 times 3 is 27. So I make it minus 27 plus 1. And then I got my minimum minus 26. That's probably how I would have done it. All right, so what do we have over here? I guess we're just graphing this function. Okay, I guess we're graphing it, but I know those graphs are done. I don't remember what I asked. Okay, so let's just look at the number 24. What are we doing to it? As x's get bigger, we're multiplying it times 3, multiplying times 3, multiplying times 3. In other words, we're always multiplying times 3 as we move left to right. So what happens if I'm moving right to left? Then I'm multiplying by a third, multiplying by a third, multiplying by a third. Okay, so if we started with 20, make that 24 units. Let's say that that little altitude, because that's what amounts are, they're ascertained by looking at the y-axis, right? So let's say we have an up and down from here to here, and that's 24 units of change. If I triple it, and if I triple that, we can see from the moment I have 24 units, then I've got 72, then I've got 216, I believe, right? But in this direction, well, then I got 8, 1/3 of 24, and then 8/3, right? And that's headed towards Zippo. So as I move to the left, that calculation is going to 0, which means the entire calculation is going to 7. All right, so I may be doing the wrong problem here. Let's just look at it from a graphical standpoint. So y equals 7. We got the signature of exponential growth. My first jump is 24. My second jump is 72. So I wrote 3. How do I get that? Well, I like to do 3 to the 0 and 3 to the 1. 3 to the 0 is 1. That's why I'm writing 27. So what makes it 0 up here? The number 1 gets me 24 plus 7 is 31. And we're only changing by 1, right? Changing by 1. So it looks like 2 gets me 72 units on top of 7, 79. Okay. And you can replay the video. I know a number of you, but the majority of you know how to do that now. Those of you who are still looking at it probably got maybe Oh, quite a few less repetitions of looking at that than the folks who can do it. So it really comes down to work ethic. And you still have time to make up for what might be a lack of work ethic. Considering that the first graphical test we gave, a standalone graphical test, I think you know the results of that one. And then that changed pretty quickly when we did it again. Reps. All right. So again, platform of y=7 should be talking about domain and range. So if this is the X ruler, looks like this does continue to move to the right forever. And it looks like it's easier to see movement to the left. I don't think there's any number I can't evaluate here. Remember, 3 to a negative is simply multiplication by a third. I don't think there's any number I can't multiply by a third. Tripling in the right direction. I don't think there's any number I can't triple. But every number does not come out of this equation because this is really not here. That y value is bigger than y=7. Maybe only 0.01 bigger, but it's bigger. So what's the range? Y values have to be bigger than 7. And you can try to find something that's 7 or smaller. Be my guest. Good luck. All right, now what? Well, I better find this sheet so I know what's being asked. All right, let's put. I hope I had that centered properly. Okay, let me go look for that worksheet. I got lucky. I found it. Hey, what do we have here? Number 33 that requires glasses. This requires some glasses. I have them. I know where they are. Oh boy, everything's gonna be okay here. 33. Find G of f of 23. Okay, G of f of 23. Let's this way a little bit more. Okay, we're there. So G of f of 23. So I gotta look at f function first. Oh, that's this one. Then I gotta drop 23 in. 23 minus 7, 16. Square root of 16 plus 14. 4 plus 14 gives me 18. Okay, so I have now. I'm now looking at G of 18. Oh, that's an easy one. Okay, G of 18 is equal to 2 times 18 minus 15, which is 36 minus 15. 36 minus 10 is 26. 26 minus 5 is 21. That's one way that you can do your subtraction, work with base 10. Hopefully I didn't make a mistake, but my brain is getting tired. We know what happens when that happens. I get silly, so let's keep going. 34. All right, 34 is the inverse of G. Of course, if you didn't know what I just said, that means the inverse, then, it's a language class. Not much you can do with the math. You got to know what the commands are. I like to, when I have a singleton, when X is alone, I like to think about solving an equation for, let's say, 103. So how would I solve that equation for any number? Maybe I want 104. All right, for any number, what do? Got to add 15. That's a new number. Got to divide by 2. How do I check if this works? Well, let's pick an easy number to work with. How about we pick the number 8? Okay, so G of 8. 2 times 8, 16 minus 15 is 1. So therefore, the inverse of 1 should take me back to 8. So let's put 1 into the inverse function. 16 divided by 2 is 8. I'm moving on. Okay, that takes care of, I definitely am not going to go and summarize all of these again. So All right, so this is just pure memorization. Like, you gotta have somebody explain this to you and do this just to get it right here. I can't explain it again. I've done it too many places. Oh, sorry, minus my plus y squared. Yeah, no, that's just fatigue on my part. I'll do it out. M times m squared, m cubed. Do I want to do it with numbers? Yeah, let's do it with numbers instead. That's a slightly different perspective. Let's let m equal 2, and let's let y equal 3. Hopefully those will be fine. 2 cubed is 8, 3 cubed is 27. We get 35. If this is true, I should get 35. M, 2, y, 3, m squared, 4, minus 2 times 3, 6, plus y squared, 9. All right, so that's 5. Minus 2 plus 9 is 7. By God, 5 times 7 is 35. I'm moving on. Now, that'll work for any numbers. Okay. What do we got here? Greatest common factor of 14 and 18 is, I believe, 2. I don't think there's any number bigger than 2 that goes into 14 and 18. 8 of the what? We got 8 of the 20 and we got 8 of the 16th. I wonder what's common. Well, I think 8 of the 20th could be written as 8 of the 4 times 8 of the 16. I think 8 of the 16 is common. Looks like the smaller of the two exponents is the greatest common factor. That's the smaller one. Now, we just have to build back the first number. And 2 times, it looks like 7 gets me 14. And 8 of the 16 to 8 of the 20, I guess we need that 8 of the 4. All right. And x to the 9 we already got, so let's stop there. 2 times 9, positive 9 gets me 18. I already got the 8 of the 16, but I got to get from 9 to 27. And I think that's 18 more. I'm not checking that with numbers. I don't feel like doing something to the 16th and something to the 20th. All right, is this redundancy? Not quite. No, this is minus a half. Hopefully you're just looking at it and writing your answer at this stage, some of you. And for those who aren't sure how to get that, well, this is how you can get it mechanically. You got to know what it's being asked. So there's a nice little witch's hat. Okay, so 25 to the what? That's what it's asking you. Gets me 1/5. Well, you got to have the same base. 5 squared is 25, and to the x, multiplication in that case, 5 to the negative 1. So therefore 2x equals minus 1. And there x equals minus 1/2. So what do we have? Reciprocation and square rooting. So if I reciprocate, well, it doesn't matter which one I do first. Let's do the square root of 25, which is 5. And if I reciprocate it, I get 1/5. That's what's going on exponentially. All right, I am going to erase. All right, we're getting there. All right, so what do we got here? We got, understanding those exponents. So what do we have? We got 3 operations. What are those 3 operations? Squaring, cube rooting, reciprocation. Does it matter what order? No. So let's take the reciprocal first. Let's use that minus sign. Then 1 over 27 becomes 27 over 1, and we still have to do the 2 over 3. Obviously, I didn't have to write the over 1. It's understood to be that, but I'm writing it in case anybody is still having lingering trouble. All right, I'm going to take the cube root next. So I did the reciprocation. Now I'm going to do the cube root. And the cube root of 27 is 3, and 3 squared is 9. All right, so where lies difficulty in name that tune? Some people confuse this function with logarithms. And those are the 2 types of logs we've been working with. And this one gets confused with that one, but the ranges are very different. This range goes to positive infinity to negative infinity. Those are the y values. Oops, get that mark off the floor. Those are those y values, whereas these y values have a maximum. And what is that maximum? It's 7. Right? There are no more y values on that graph. Right? So what are you looking at? Square root. All right, so smallest a square root can be, a square root is the side of a square. We can make it smaller, we can make it smaller, we can make it smaller. Smallest it can be is 0. So this thing starts with x minus 3, so we get the square root of 0. And how do we match that up with a 7? Subtraction does it for us. Square root of 0 is 0. Why? Because 0 times 0 is 0. The square root of 9 is what? 3, because 3 times 3 is, right? So square root of 0 is 0. So it exists. And how do we get from 7 to negative 9? Looks like we go down 16 and 3 to 17. Well, if I put a 17 in here, then I now have created this. And if I'm not mistaken, that does not equal that. So I think I want to get rid of this. So it does equal that. You say, how you can do it? How can you do that? That was easy. I had the marker. Okay, so what's the answer? Okay. And if you're still not getting that, then this is where the preliminary warm-up will help. We can do it again. You play the video again. You look at it. And you do this thing called thinking. And sometimes you have to think for a while to solve a problem. Oh, I'm sorry. Here we go. So distance. Doesn't matter what quadrant you're in, right? The bottom line is we're moving from -2 to 7. That's the change in x, which is 9. Okay, if I have a change in x of 9, whether it's positive 9 or negative, doesn't matter because we're gonna square it and we're gonna get 81. How do I get from 8 to 9? I'm changing by 1, and that square area is 1. So if I drew it to scale, I'd have 9 and 1. Okay, well, that area is 1. 9 is 81 units of area. Then the distance, Pythagorean relationship, gives me an 82. Okay, so 82 minus 1 is 81. 81 plus 1 is 82. 82 minus 81 is 1. Okay, so what are we doing? We are changing horizontally and vertically. So we're going to add up those two square areas. We're going to add up the 81 and the 1. Remember, the size of it doesn't matter. So that square area is 82. So what is that length? Square root of 82. All right, now we're going to do 4 graphs. I'm going to do them quickly because I'm running out of gas. So number 5, 3 times the absolute value of 4x minus 8 plus 11. 4x minus 8 is a linear function that crosses at 2. If I slap it with an absolute value, then the negatives become positive. So we have a V-shaped graph, and we know it starts at x equals 2. I put 2 in, I get the square root of 0, which is the smallest distance you can travel on a number line, because absolute value measures how far you are from 0 on a number line. If you're at 0, I guess you aren't very far from 0. So 0, 0, 11. Very similar to the quadratic, very similar to the square root function. Okay, it gets us our starting point. I've been asking you to simply, well, let's put an x-axis here because this people have had trouble as to which side the y-intercept's on. That is 2. I'm centered at 2. Where is 0? What do we do with x values? Do the math. I actually love running a no-talk soccer practice. It's always the best we ever play. Yeah, only did it once in a game. And a team, younger team played an older team. We actually won the second time we played them because we didn't talk. Looked around, better decisions. So that's that graph. Of course, if you want to put another point in here, you can put 4,35, right? And let's actually solve this equation. We got two numbers that produce 35. So let's set this to 35, get one more practice here. Something that's going to be at the end of the, worksheet, I think those three questions. Writing it piecewise, solving for equation, which we know our answers are 0 and 4. We're going to get them really quickly. This was a V shape. So you're going down, then up. So down is -3. 4x minus 8 plus 11 equals 35. I think that was the one that gave us 0. So let's see how 0 tops out. Let's take away 11, 24, divide by -3, -8, add 8. Oh, there's 0. 4 times x equals 0. There's our 0. The other answer was 4. That's this. So let's solve it. Oh, that's 24. Oh, that's 8. Let's add 8. That's 16 divided by 4. There's 4. All right, minus 2x squared plus 20x minus 3. Right, y equals, okay? So what do we have? We want a quick graph. Boom, there it is. Cup shape down, okay? I'm on the increasing side. The 0 gets me 20. So therefore, 220 is 10 cut in half. I know it's 5, but you feel free to do minus b over 2a, which is minus 20 over minus 4. There's your 5. Plug in a 5. There's 100 cut in half is 50 minus 3. There's your 47. And so therefore, we now know that 0, 5, 10. 10 gets us height of 20. All right, so how do we solve that? Well, if we want to get 20 units, I think we rewrite this because I sure don't want to have to be dealing with the quadratic formula. I don't work with it anyway. So we just put it in graphing form. Minus, we don't even have to do that, right? How do you get from 47 to 20? You got to go down 27, right? And you're dividing by what? -2, and that's a plus minus. So we really, if you're on top of your game, then you already have the answers to those problems. Okay, but let's actually see where that came from. So graphing form, -2 x minus 5 squared plus 47, and we want to get to 20. Let's just do one. Let's get 10 as an answer. Well, we get both of them at the same time. So we subtract. So minus 27 takes care of getting rid of that. Dividing by -2 gets us that. Squaring is plus minus, and that gets rid of that. And then we got our 5. And I hope that at the end of the video, did I finally run out of gas and do something stupid? Oh, 47 to 20, 27 units. But 0 gets me 20, right? Oh, God, what a mistake that was. Woo! Good thing I did this. 0 gets me what? Oh, my God. -3. What did I do? I think I said I wanted, I just made something up. 0 gets me -3. So therefore 10 gets me -3. Okay, so I'm not going to redo this, but this is the kind of thing that happens. And it did. So let's go back and find these numbers for -3. Ooh. All right, so how do you get from 47 to -3? You go down 50. You have to divide by -2. Okay, you got your plus minus square root. And then you've got your from 5. All right, so that's a little better. All right, so that's going to be 50 divided by 2, which is 25. Square root of 25 is 5. 5 plus 5 is 10. 5 minus 5 is 0. Okay, so the thought process, if the old guy was actually thinking about what he was doing rather than mechanically just doing it, works fine. Okay, and if we wanted to change some numbers, go through the same process. All right, let me get this done with before I completely botch everything, because I'm at that stage of needing a break from doing some computations. So where am I? 3x squared plus 12x plus 7. Okay. All right, so if I wanted to know something about this, I know it's a positive 12, 4 divided by 2, 2 squared, 4 times 3, 12, so minus 12 plus 7. I got something to work with. Okay, so from your standpoint, where might you be at this stage? Well, you're probably cup shape up. Okay, probably needing to get the vertex first still, although I'm hoping that maybe folks see that starting to hear this enough repetition that might be helpful to see why. I could break this thing up into 2 graphs, right? And it's the sum of those 2 graphs. It's the sum of those 2 graphs that I'm looking at. So let me graph it from that perspective. 3x squared, smallest that can be is 0. And I'll graph just a cup shape at this stage. It's probably, depending upon what I got for x and y axis, we could get how narrow it is. 12x plus 7 is a linear function. Okay, so what is this function doing at 0? It's going up. What is it doing at 0? It's flat. Okay, so when you get to a higher level of math, you'll learn about rates of change. And in a polynomial, each term contributes a certain rate of numerical change. And we can see that if one is 0 and the other is positive, if you add those up, you're going up. All right, so now we know we have a cup-shaped graph. What side are we going up on? Well, you follow from left to right. Left to right means that as your x's get bigger, you're coming down to a minimum and then going up. I'm on the upside of a cup shape up. It might help some of you. All right, but for those that still is, something that you got to get more reps and think about if you're going to understand what I was just talking about. I am losing my train of thought, and you've seen the Wizard of Oz, which starts to melt. That's what's going on in my brain right now. Starting to. All right, here we go. So minus b over 2a, minus 12 over 6, negative 2. Okay, so which side? I told you I'm melting. Cup shape up. Oh, yeah. Jeez. Oh, Lord. Okay, I'll get through this. All right, negative 2 squared minus 24. So therefore minus 12 plus 7. But let's show you why. So negative 2 squared 4 times 3 is positive 12 plus 7. Hopefully you're starting to see that shortcut. So minus 12 plus 7, minus 5. We throw a 0 in, we get a 7. Okay, it's helpful to know that if you went from negative 2 to 0, you changed by 4 units, by 2 units, but the quadratic is 4. How do you get from negative 5 to 7? You got to go up 12. How does 12 compare to 4? It's 3 times that jump. Okay, so I just wanted to hit that one more time. All right, so minus 2 minus 5, 0, 7. So therefore negative 4 gets us 7. So let's solve this thing for 7. How would you do it? Well, hopefully you have a lot of different tools in your toolkit. I think I'd subtract 7 here, make that 0. And that gives me 3x squared plus 12x, which is easily factorable. It's 3x times x plus 4. And there I can see my 0 and my negative 4. And I can also see my number in between. So a lot of different ways of looking at math. That was one. Of course, we could have put it in graphing form, right? We could have said 3x plus 2 squared, what was it, minus 5? Set that to 0. Right, for roots, or 7, I think it was the y-intercept we were looking at. So what do you got? You got 12, you got 4, you got plus minus 2, And then you've got your x's are -2 plus -2. There's your -4, there's your 0. Lots of different ways to do things. All righty. Let me end this thing right away. X plus 8 times x minus 6. Most of you multiply that out to get ax squared plus bx plus c. My suggestion is to take what's given to you. You've got a couple of critical x's. What are they? You're -8, they're +6. What are you looking at? You're looking at x squared, cup shape up, right? So there's your 0 for an altitude if this was our x-axis. And what's between -8 and 6? I believe it's -1. Right, so -1 plus 8 is 7. That's probably -7 pattern that comes out. Yeah, -1 minus 6, -7. So you got -49. And the x squared has a 1 in front of it. So how do you get from -49 to 0? Got to go up 49. All right, and why am I doing this? I don't know. Totally lost my thought process. I'm ending the video now so I can escape and have some semblance of the day ahead of me. And that's what we did. We did 21 to 40, I believe, on the worksheet. And I'm sure as heck not going to tackle 41 to 60 right now. No way. All right. So whatever problems those are giving you trouble in class, feel free to ask for some extra types of problems like the ones you're struggling with. Again, we're looking for your best effort in the next month. That's what your grade will be based on. How many things you know can prove to us that you know. And hopefully you're gonna see your correct responses go up quite a bit in the next 5 weeks. All right, done.